So compounds, combining chemicals from the periodic table. This is the last chapter in the chemistry unit. Probably the toughest one. Now, I said this is the last chapter. I am thinking about, Nick, actually covering one of the toughest ideas in Science 10 this year, just to give you guys a head start for next year. I taught Science 10 last year, and there comes a point in the chemistry unit where about half my class just runs into a wall. They find it very tough. If you have any older siblings, it's balancing equations, which is nerdly cool, but really tough to wrap your brain around. So I'm debating with Hannah, I might do a little mini session topic of a couple of days so that when you see it next year, instead of going, huh? You go, oh yeah! We'll see. Is that okay? I care. We'll see how it goes. What is a compound? Well, it's formed when two or more atoms are joined together through chemical bonds. There are two main types of chemical bonds that we'll be talking about this year. One we'll be focusing on a lot this year. The second one I'll talk about, you'll be looking at it more in Science 10. As an example, water is H2O. H2O is really the, well, if you want to say it, formula for water. What do you think the numbers and the letters in this formula means? Well, some of this, hopefully, you know. What do you think the H stands for? Hydrogen. Nice. What do you think the O stands for? Oxygen. The real question is, what does the 2 stand for? 2 hydrogens or 2 oxygens? You were right. Say it loud and proud. 2 hydrogens. And even more specific for every oxygen. That's, in other words, if you wanted to make 2 molecules of water, you need 4 hydrogens and 2 oxygens. If you want to make 10 molecules of water, 2 times 10 is, you need 20 hydrogens and 1 times 10 oxygens. This is how we're going to start to build words from the alphabet of the universe. So, in our notes, you can write down H is for hydrogen, O is for oxygen. The 2 means that there are 2 atoms of hydrogen. Oh, and if there's no number, what number is really down there? It's invisible, but 1. Just like in math, when you write an X, we know that in front of it there's a little invisible 1. Okay? Pardon me? Okay. So it's not a bad system. As usual, you may have noticed in chemistry, lots of information packed into just a few characters. We you know, tend to abbreviate, right? How are elements joined? I don't think I had this in your notes. Maybe I did. Well, there's 2 possible ways. So I want you to imagine 2 kids playing with a toy truck in a sandbox. What are the 2 main ways they could interact? Well, if the kids are nice and they both want to play with the truck, but they're nice, what could they do with the truck? Share. Share. Cooperate. If one of the kids is not nice, what would they do instead? Mine! Not yours. And it's funny, but that's the 2 ways chemicals can combine. Now, instead of a truck, electrons. 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 And they can either, mine, take electrons, although metals are generous. They're happy to say, yours, and they don't want to play with the truck. Or they can share. Or they can share electrons. The sharing of electrons happens between nonmetals. Nonmetals are so desperate to have that full valence shell that they're willing to share electrons with another nonmetal to get a full valence shell. And those are very strong chemical bonds. Yes, most of those end up, most explosives have that type of chemical bond. But yours, it's actually a very weak chemical bond, but it's the easiest one for us to start with. It's the easiest one for us to wrap our brain around. You don't want them, I'll take them. I don't want them, you take them. Okay? So, atoms are just like the kids. Remember that the atoms want to have a full valence shell. Good. Remember, valence is the outer shell. Oh, you know what? I was going to put the word outer, but full valence or outer shell. Okay? There are two ways that they can get that. What two ways, you ask? Well, the first one is they can share electrons. And this next word, you want to put a star beside, you want to put a box around. This is going to be a vocabulary word. You need to know this word. We call this a covalent bond. Now, kids can usually remember the word covalent. What they have trouble with is remembering what type of a bond it is. So we're going to go a little Sesame Street on you. So a covalent bond, we share. Another word for share from Sesame Street is the word cooperate. What are the first two letters of the word cooperate? Co. Covalent, cooperate, share. You're sharing. You're not taking, you're sharing. If you're wanting a dumb way to remember that covalent bonds share electrons, they're cooperating, they're covalent, they're sharing. Ah. The second way is they can steal or lose electrons. We call this an ionic bond. So in an ionic bond, you're saying mine. What's the first letter of ionic? It's all about I. Me, mine. If you're looking for a dumb way to remember that in an ionic bond, metals totally get rid of their electrons and nonmetals totally say mine. Not as strong a chemical bond, it turns out. Covalent bonds are always between non-metals. In fact, when you look at a chemical formula, if you see that the first chemical is a non-metal, it's covalent. Remember H2O? Hydrogen is not a metal. That's a covalent bond. I can tell you that right now. So, electrons are shared. So one or more electron is kind of doing a double duty by allowing the valence shells of two different atoms, or more, but we'll keep it simple, two different atoms to be full. Did I give you this picture in your notes? I did, yes? Yeah. Okay, this gives you an idea. So here is a Bohr model. The big red atom is oxygen. You know how I can tell? Because it has two shells and its outer shell is full. Also, I've told you that the chemical formula for water is H2O. Put an O next to the electrons from oxygen. How many electrons does oxygen have? What's its periodic table atomic number? 8. So normally, it's not an ion this time. How many electrons will it also have? Same number. So you ready? There's 2, 4, 6. How many more? That one there and that one there. There's the 8. How many electrons does hydrogen have? What's the atomic number of hydrogen? 1. How many electrons does it have? You know what? Right there, that's an electron from hydrogen, and that's an electron from hydrogen. But by sharing, in that outer shell, how many electrons does oxygen have in its valence shell? See the full 8? 2, 4, 6, 8. And how many electrons does hydrogen have in its valence shell? 2, and that's what it needs. Okay? This is called a covalent bond. It's a covalent bond. They're sharing. let's try doing a Bohr model of HF, what we would call hydrogen fluoride. Okay? So how do we draw this? Well, over here, that's going to be fluoride. That's going to be hydrogen. You know what? Let's draw hydrogen last. If you started, that's okay, but trust me. Fluoride, how many protons? 9, or is that a German saying no? 9. How many neutrons? 10? Okay. How many protons? 9. And since it's an atom, not an ion, how many electrons? The same number. So in the innermost shell, we'll have 2. How many more do I need to draw? 7. And that's going to be in the next shell. So it's going to look like this. 1, 2, 3, 4, 5, 6, 7. It's not happy. Now, next to it, we're going to draw a little hydrogen. I'll do the hydrogen in red, just so it's a different color. Oh, I didn't write the hydrogen. Let's do this. Oh, you know what? Let's be clever. Let's put a big F underneath here so we know that one's the fluoride atom. So here's the hydrogen nucleus. I'm pretty sure it's 1 proton, and hydrogen is the only one that has no neutrons, right? Because its mass is 1. If you go 1, take away 1, 0. It's why it's the most common element in the universe. It's so easy for it to be formed inside stars. It's the simplest element out there. How many shells does hydrogen have? Now, when I draw it, I'm going to go like this, and I want to try and intersect like that. I know it's a terrible circle, but I'm less concerned about the circle and more concerned about showing what's going on. And its electron is going to be sitting right at the intersection right there because its electron is being shared by fluoride. Now, fluoride has a full shell. See the 8? And hydrogen is sharing that one electron with fluoride is sharing that one electron with hydrogen, and now hydrogen has its full shell too. By the way, don't write this down. This is all garbage. This is all wrong. Really, this electron is sometimes jumping over here. This electron is sometimes jumping. All these electrons are jumping around all over the place. The electrons are not standing still. They're not static. But, Nick, this is a good model. This is a good analogy. This is kind of what's going on. But what's really going on is way more complicated, and that's a rabbit hole you can dive down, and the whole books have been written about it. But for now, Brady, this is what I'm going to say is our model. Okay? Ooh. SiO2. All right. How many silicons are there? How many oxygens are there? 2. So here's your hint. You're going to put the silicon in the middle and the oxygen on either side. You know what? We're going to draw the silicon first. Okay? Silicon I'll do in black. Oh, you know what? I forgot to put an H under hydrogen, didn't I? Go back. Put an H there if you didn't already. Silicon is going to be done in black, so here's the nucleus. Wow, that's terrible, Mr. Dewick. You can do a little better than that. Not much, though. That's the sad thing. Silicon, how many protons? 14. How many neutrons? 14. Also 14? Okay. How many shells?
3.
Silicon's got 3? Okay. So it's going to be 2. 1, 2, 3, 4, 5, 6, 7, 8. You said 3 shells? Okay. How many will it have in its valence shell? 4?
Yeah.
Okay. I'm going to go like this. This is a tough one to draw. Hang on that outer shell. I know I'm going to put 4. Let me come back to it. How many oxygens are there?
2.
Okay, so I'm going to do oxygen in blue because blue seems oxygenish-y to me. Oxygen has 8 protons. How many neutrons? 8. How many shells? 2. See how easy this is now? How tough it seemed a month ago? So now, here's what I'm going to do. Okay. Like that. And over here, I'm going to do another little oxygen. 2. And then D. Alrighty. Let's see how this works here. How many electrons does oxygen have in its outer shell? In its valence shell? I don't think it has 6. Okay. 6. So I think I'm going to go like this. 1, 2, 3, 4. Let's see. I got to figure out how to make this work here. Five, 6. 1, 2. I may have to change this. Hang on here. Because I want silicon to have how many? 8 as well. So I want silicon to be sharing some of these 6 with oxygen, and silicon normally has 4. How the heck am I going to draw this? I always have trouble with this one, and I'm blanking again. Give me a second here. You know what? I think it's going to go something like this, actually. So first of all, let me be consistent in my coloring. I'm going to do the oxygen electrons. Oh, you're not going to let me go that far back? I'm going to do the oxygen electrons in blue. Oh, hang on, Duke. Okay, here we go. Wait, just hang on. Let me put this all together. Okay? I need 1, 2, 3, 4. Just watch. 2, 3, 4. There's going to be an oxygen here, an oxygen here, an oxygen here, and oxygen here. That's 6, yes?
Yeah.
Okay. Now, we also want to have a silicon right here, a silicon right here, a silicon right here, a silicon right there. Does that give me 8 for silicon? And that gives me, if I imagine this is also on this ring, that gives me 8 for oxygen and 8 for oxygen. And I'm not going to give you one this tough to draw, but this is kind of, sort of what's going on. These are covalent bonds. Okay. What we're going to spend a lot of time on is the next one, ionic bonds. And here's what you want to memorize. Ionic bonds are always metal first. Oh, you know what? First can go in brackets. That's what I had in mind. And a nonmetal. In the order, we always put the nonmetal second. And what that means, Kevin, is at a glance, you can tell right away whether something is ionic or covalent. I'm going to zoom in on this a little bit here. What would be a good letter to use as an abbreviation for ionic? Ionic. Okay, I'll use capital I. What would be a good letter to use as an abbreviation for covalent? C. So it says, this is from your homework, but we're going to do it together. Identify each of the following compounds as either ionic or covalent. What I don't like is A is weird. They start off with the weird rule breaker right away. So we're going to skip A. Look at B. Oxygen, metal or non-metal? Covalent. You know what? Let's not use black. Let's use red. SN, metal or non-metal? What is SN? Oh, tin? That's going to be ionic. Nah, metal or non-metal? It's ionic. So now I'm going to ask you the same question, but I'm going to phrase it differently. Ionic or covalent? How do you know? There you go. Ionic or covalent? Ionic or covalent? Ionic or covalent? Okay. And in fact, one of the first questions whenever you see a chemical like that, in fact, probably the first question you're going to ask yourself, Mason, is ionic or covalent? What you're really asking yourself is, does it start with a metal or not? Now, it turns out that there's something called a you going to make it? That was a nice long blink. You going to make it? There's something, Franz, called a polyatomic ion, and it behaves like a metal. So next to A, you can write, did I include this part in your notes or not? I can't remember. Okay. That one there is ionic, but I won't tell you why yet, Danielle. It's a rule breaker, but you'll understand why later. Okay? Shrink back down. So, when we're talking about ionic, we say this. One atom steals an electron or electrons. The other loses. In fact, I can be even more specific. Next to steals, if you want to, you can say non-metal. Next to loses, if you want to, you can say metal. So here's a little picture. Did I include the picture in your notes? I can't remember. Okay? But I did include the blanks, right? So sodium, has only one electron in its valence shell. I didn't leave you much room to write valence, sorry. If it loses it, its outer shell is now full. Yay! Chlorine only needs one electron to fill its outer shell. So chlorine steals one electron from sodium. I'm going to zoom into this picture just so you can get the full effect. I'll bring the notes back in a second. So sodium wants to get rid of that electron. That electron leaves sodium and attaches it to chlorine. Now, because sodium has lost an electron, it's an ion with a charge of plus. And because chlorine has gained an electron, it's an ion with a charge of minus. We would write it like this. Plus 1, there's your square brackets for ion. This is a sodium plus ion. This is a Cl, a chlorine minus ion. And what would happen is, right here, there would also be a chlorine ion. Right here, another chlorine ion would attach itself. Right here, a sodium ion would attach itself. You get this crystallized, what we call a crystal lattice, this pattern of, in this case, chlorine, sodium, chlorine, sodium, chlorine, sodium, in all directions. But also, it has to be three-dimensional. So right here, there would be a chlorine ion right next to this sodium ion. And right here, there'd be a sodium ion right next to this chlorine ion. This is where it's tricky or mandy to imagine it. But it goes 3D. Okay. If we were going to draw a picture of lithium fluoride, of LiF, how many lithiums are there? One. How many fluorides are there? One? Okay. So, if we were going to draw a board diagram, let's start with lithium. Yoink. Now, you ready? You can, if you want to, put the protons in the middle like this, or if you want to, you can just draw them underneath, whichever is more convenient for you. You know what I'm going to start to do? I'm going to start to just color in my nucleus so you can tell it's a nucleus. And I'm going to put the protons and the neutrons down here. So lithium, which is Li, how many protons does lithium have? 3? How many neutrons? 4? Is it 7 take away 3? 4? Okay. Now, in the first shell, lithium has 2. And then once you've written that, put your pencil down. Don't write this next bit down. Normally, I would do that, but what's happened to that one single electron? Okay, so I'm not even going to bother. I'm going to go pick your pencils up. I'm going to say this is a lithium plus. In fact, I'll even put a plus next to the lithium down there. This grace is a lithium plus ion. Now, what's it bonding with? F. Okay, I'll do that in black. So here's F. How many protons does fluorine have? How many neutrons? There's my nucleus. Fluorine has one full inner shell. And then fluorine is in period 2, yeah? It's got 2 shells? I'm trying to keep them small. Like I could have done chlorine, that's a whole extra shell. Heck, I could have done like iodine or something further. That's too many shells. We can draw it, but I'm not going to do, that's overkill. Fluorine normally has 1, 2, 3, 4, 5, 6, 7. But what? So I'll put a blue one on there. That would be a Bohr diagram of a lithium fluoride atom, an ionic bond. 2 ions coming together. Now, why do they come together? When we do electricity, you'll learn that a positive charge is attracted to a negative charge. It's actually static electricity. It's not a very strong bond. Covalent ones are much stronger, but okay. In fact, these are weak enough that most of these, if you put them in water, they'll dissolve in water and the bonds will break apart. That's why salt, for example, which is an ionic compound, dissolves in water. Is this ionic? How do you know? Okay. I should have really asked that last time here, too. I should have said, is this ionic? It is. How many berylliums are there? How many fluorides are there?
2.
I'm going to put beryllium in the middle and a fluoride here and a fluoride here. Kind of like Mickey Mouse ears, but not up at an angle. Okay? So I'll do the middle one first, beryllium first. Be. I don't know beryllium. 4? How many neutrons?
5.
Sorry, how many? 5? Okay. So there's the nucleus. Geez, my circles are terrible. It's got 2, and then normally, don't write this down, Normally I would add 2 more, but I think we're saying it's getting rid of those puppies, right? That's the next shell. So we can just say, boom. But what's the charge on beryllium when it becomes an ion? 2 plus? Fluoride. How many, I forget, how many protons fluorine has? 9? And how many neutrons? 10. And so it's got 2 on the inner shell. And normally it has 1, 2, 3, 4, 5, 6, 7. But what, Brady? Beryllium gives 1 electron there. I show that it's an ion with the square brackets, and its ion charge is 1 and 1. This chemical compound would not be stable, though, because beryllium still has 1 more electron it got to get rid of. I need another fluoride. I'll put it on the other side. You guys are going to hate me. Copy. Paste. There. Draw away. In fact, you know what I could really do? Oh, I don't want to do that, Mr. Duick. That was bad. Okay, let's paste. Click. Then I could go like this. Don't do that. I can move this a little closer so they're like really bonded. There we go. And then I could go like this and move this a little closer. There. There is a lovely beryllium fluoride compound. And again, where it gets tough, Nick, is I would also have to imagine this is all three-dimensional. There would also be a little fluoride ion float like right here above it and into the screen behind it. And there'd be a, oh, this one's a bit tougher to visualize. The previous one where it was 1 and 1, I can just remember it goes every other, every other, every other. At this one, I'd have to really look at a model 3D and see what it looked like. Is that okay?
Yeah.
Even with the copy and paste, you guys made it okay?
Yeah.
So, ionic compounds form, and this is a word you want to know, an ionic lattice. I can't remember if I put that in your notes as a title or, okay. So we think of and write ionic compounds in lowest terms. So, for example, NaCl is the chemical formula, but it's really N1 million, C1 million, or N1 trillion, C1 trillion. But what I'm saying is, for every sodium, you need 1 chlorine. It's lowest terms. Or for this one here, this is a three-dimensional model of NaCl. And this is what kind of helps you visualize. They're found as a network, and here is our word that we're going to write down, called an ionic lattice. A lot of these look kind of crystal-ish. Okay? Sounds like ionic lattice. If you write that on a test, sadly, you'll get it wrong, so I wouldn't memorize it that way. Is that a hand up? No, just twitching the pencil? Okay. Put your pencils down. So, what do you need to remember? Covalent bonds are always between nonmetals. So this, really important. I guarantee on your test, I'll give you a list of compounds and I'll say which ones are ionic, which ones are covalent. If there is a metal present, it's an ionic bond. Now we need to go one step further. You ready? Turn the back of your periodic table over. Look at the back. We haven't done this yet, but this is the universe. What does it say as a heading for that big chart? Some polyatomic what? Ions. So it turns out, we've been talking about ionic bonds, which means you need ions. It turns out that there are some covalent compounds that when they form, they're charged, they're ions. One of them is positive. What's the only positive polyatomic ion you see there? Look at the chart. What's the only positively charged polyatomic ion, and what's it called? What's it called? But there's a name there. I guarantee. Ammonium. Okay? Used in ammonia and other things as well, but ammonium. Okay? That and that one there, even though it starts with N, which is a nonmetal, NH4 behaves like a metal. That's why earlier when I said there was that one weird exception when I gave you this chart here, NH4 behaves like a metal. This one is an ionic bond. Now, then there's a whole bunch in the right-hand side of the column. All of those, Mason, are compounds that actually behave like a single funky charged atom. Well, they're weird. Okay? So, back to our notes, but keep the back page handy. If there is a polyatomic ion present, it's also an ionic bond. I can't just go metal, non-metal. What I will say is if you see one of those ones from the back of that sheet, trust me, it's also ionic. Now, okay, nerd moment here, Mandy. There are covalent bonds that form those polyatomic ions. They're formed covalently. They're sharing electrons to create. Give me what's the first one on the negative side? C. Oh, you know what? I got it right here. Okay. So acetate, which I jokingly call chaku, that looks like that. That's a covalently bonded molecule. But you'll notice when it forms, it has a charge of -1, which means it will behave like chlorine, or like fluoride, or like any of the -1s. It'll bond the same way. Or if we go cyanide, ooh, I've heard about that. Isn't that what the spies swallow to, yeah, okay. See, find cyanide, it's partway down. See it? Find it on the chart, okay? CN is its chemical formula. It turns out carbon and nitrogen can bond covalently, but now they'll act like one single nonmetal with a charge of -1. They'll bond ionically. And this is where it gets pretty tricky. I told you, this isn't the easiest unit. So I wrote here, what are the polyatomic ions? See the back of your periodic table. You absolutely don't need to memorize them. But Ibrahim, you do need to spot them, ding, 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 when you see them in a chemical formula. You'll be able to spot them because, oh, there's more than 2 capital letters. There's more than 2 elements. What are polyatomic ions? Well, turns out the word poly means many. Atoms atomic refers to atoms. So a polyatomic ion is literally a many atom ion. It's an ion, it has a charge, but it's made up of more than one atom. There are thousands of polyatomic ions, but for Science 9 and Science 10, these are the ones that you're going to be using quite a bit. You'll also notice that I've given you what they're called. You'll also notice some of them have more than one name. Can you find me a polyatomic ion that has more than one name? Hydrogen carbonate, which is also often called bicarbonate. The naming between you and me is stupid. The rules are stupid, but they are what they are. I would never have set up the rules for naming chemicals this way. They drive me crazy because they're confusing. And every time I give you a rule, Alyssa, there's like 10 exceptions to the rule because tradition drives me crazy. But it is what it is. The atoms in a polyatomic ion are held together by covalent bonds, but they have an overall charge. If you look on that back sheet, every one of them, ammonium has a charge of +1, and the rest have charges of -1, -2, etc., etc., etc. And so the group will act, and this is why, Brady, I said they act like one weird, funky atom, because they're not an atom, they're polyatomic atoms, but you can treat them like one atom in terms, we're not going to try and draw it, but when we're doing our chemical formulas, we'll treat them as one weird thing when we do our arithmetic and math and figure everything out. So they act as one unit when forming ionic compounds. Covalent, charge, and ionic compounds. This is the only time covalent and ionic bonds are found in the same molecule. Oh, covalent, I missed the T. Now already we're getting into some pretty heavy depth. Like, whoa. You have a list of common polyatomic ions on the back of your periodic table. Be careful. Many of the names, have I gone on my rant about how much I hate the naming?
Yeah.
Okay, because many of the names are almost identical. For example, look at the bottom 2. Make very sure you read carefully whether it's sulfate or sulfite. Oh, and it gets better. There's also going to be a sulfide. There is. Or right above it, you have phosphate, phosphite, And there's also going to be a phosphide. All I can say, Matt, read really carefully. I can't change the stupid chemical naming rules. What if I could? Oh, there is only one polyatomic ion that you'll be dealing with this year that has a positive charge. Which one? I'm going to write NH4 because that's less work, but yeah, ammonium. Made up of nitrogen and 4 hydrogen molecules. I'm not going to bother, but, you know, oh, sure. It takes, sure. Since it's an ion, I really should. Good question, Hannah. Did I include this homework on your handout? No? Textbook and blah, 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 blah? Okay. For now, I'm just going to give you section 3.1 today. Next class, Thursday, we're going to be watching a video, filling in a form as we watch the video, and I'll assign the rest of this next class as well. So for now,